Alright, this is Chapter 6, Section 2. This is the second video. So before we were doing probability of under the curve, which is the area in calculus. Well, what if we want the actual value, or the number quantity of things, or the z-score, right? So I know this is more than 0, so this is a positive number, right? So if I put this probability or this area into the spreadsheet, or if I did the calculus, I would not get this z-score. I would get the first 21%, wouldn't I? Right, because I need all of this area will give me this z-score. So again, the biggest thing here is understanding how the calculus works, right? And not just plugging in numbers, hoping it'll work. So I know that the calculus works left to right. So this is not enough area. So if I put in 21.23%, that's only going to be this little piece over here, essentially, right? So this is 0.50. Plus this is the total area or probability to get to that z-score, essentially, right? Okay, so if I want to calculate that, I need to do normal dot inverse. I'm inverting the area, or i.e. the probability in statistics, back to a z-score. So 0.7123, comma 0, comma 1. Notice I'm not putting true, because true means accumulate the area. We already have the area, so you would not be accumulating. It's already been done. So take this area and invert it back to a z-score. And I know it's z because it's 0 and 1, right? If I put the actual mean and the actual standard deviation here, this will invert this back to an x, which is the height or IQ or weight where the thing is. But if I put 0 and 1, it's a z-score, essentially, right? So that is a z, essentially, right? Okay. So about 0.56, which makes sense because that's above, whoops. There we go, right? Because that is above 0, right? It's a positive z value. Plus this area is more than 50%, right? If it's more than 50%, you're over here. If it's less than 50%, you're over here, which is a negative one, essentially, right? So let's think about that as far as percentile, right? Because percentile, percentage, people get confused here. So your percentile is your location. So if it's a 95th percentile, that's 95 area. So you're more than 95% of all the people, right? So if it's in terms of men's height, the 95th percentile means you're taller than 95% of the men, correct? If you're the 35th percentile, that means you're only taller than 35% of the men. Okay, so if we do that, that is normal dot inverse, converting it back, right? So 0.95, comma 0, comma 1, right? That gives me that there. And what I can do is normal dot inverse 0.35, comma 0, comma 1, and put that there, right? So I get those two values, which makes sense. You should get a positive 1 above and a negative 1 down below, correct? So essentially, this one is about 1.64, right? Come on, pen. Come on, pen. 1.64, right? Dot, dot, dot. And then somewhere over here is, you know, the 35th percentile, right? Not to scale here, which should be, you know, z of negative 0. Was it 38, right? 38, dot, 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 correct? So negative is below, positive is above, essentially, right? All right, so you should be able to invert the area slash percent, your probability, back to an actual z-score or an actual value. So again, in this case, there's z's because the fact I put 0 and 1, right? If I put the actual means and standard deviations, it's not 0 and 1, right? Which is the point I'm trying to get to here before we do the rest of the lesson, okay? So whether it's a normal or standard normal, right? So your standard one, normal curve, right, is using the mean and standard deviation, right? And it's going to give you x values, whether those x's are, you know, IQ, weight, you know, height, or whatever the thing is you're doing statistics on, versus the standard normal, right? Standard normal, that's when you're doing z, you know, with 0 and standard deviations of 1, essentially, right? Or z1. Okay, they're related. So let's take an example of IQ. IQ has 100 average or mean, right? So expected value of 100 for IQ, correct? So my z values, are on here from -3 to 3. They obviously go beyond that, but we don't need to do the partials, right? So if my deviation is 15, this is 115, this is 130, this is 145, right? And this is IQ, correct? Or I can go one deviation below, because it's right going down. That'd be what, 85, 70, and what, 55, correct? Okay, let me get rid of some of the extra room here. All right, so what I'm trying to illustrate is the same curve for z versus the x, and the x is whatever the thing is you're actually trying to figure out the probability of, or the actual value of, essentially. It's not a different curve, it's the same curve. So all you have to change in the formula is those last two parts to figure out, or do you want the z, or do you want the actual thing, basically the actual noun. Okay? Alright, so let's look at some real problems here. So let's say we have blood is 5.2 liters is the average, right? So we have 5.2 here, right? And we want to, so this is liters, right? And we want to know people that have 5.4 liters or less, okay? What proportion of the population has that much blood in them, right? So essentially we can do it with z-score, or we can do it, so this is going to be a z is a positive number, right? So what that number is, I don't know, correct? So it'll be the same answer either way. Whether we do it z or actual values, we're going to get the same thing. Okay? Alright, so the deviation is 0.3 liters. Okay, so let's try this using both methods. Okay, let's go on another spreadsheet here. Perfect. Alright, so normal dot distribution. Right, so we want 5.4 liters or less, so comma 5.2 average with a deviation of 0.3 liters, comma true. Okay, so that's 5.4 liters or less, right? So that's a pretty straightforward one, no deviations. There's our mean, there's our standard deviation, correct? Okay, so we get about 75% essentially is the area that's in here, right? So 0.747, right? Dot, dot, dot. Okay, so if we do it with z-score, we should essentially get the same thing, right? So normal dot distribution. Okay, so we have parentheses 5.4 minus 5.2 divided by 0.3, so that's our z-score, comma 0, comma 1, comma true. So notice instead of actual value, I'm putting the z here instead, correct? You can calculate in a separate box too. So we get that, right? So let's calculate in a separate box, right? So we get what? 5.4 minus 5.2 divided by 0.3, right? So that's in the separate box. So we can just take this and delete it and put in C1, right? Because that's where the actual z is essentially, right? Same answer, right? So no matter which way you do it, you get the same answer. So basically, you don't need to do the z-score if you want the actual value, the actual noun, okay? You don't need to do that. Okay, let's say we have household trash. The average household is 28 pounds, right? And we want between 27 and 31 pounds of trash. What proportion of the population does that represent, right? So I mean, we need a negative z-value here, we need a positive z-value here, and this is obviously 0 z-value there, correct? So either way, it should work out. Okay? All right, oh, before we go on, let's put the other one up here, right? So that's what we did up there. There we go. Perfect. Okay, so let's try this one down here. All right, let's get the spreadsheet going. All right, so we want to do between two values. So we want to do normal dot distribution. So we want 31 comma 28 comma the deviation is 2 pounds of trash comma true minus normal dot distribution 27, comma 28, comma 2, comma true. Okay, so between 31 and 27 pounds of trash with an average of 28 and the deviation of 2. Okay. All right, so that middle area right there is about 62% of the population. All right, let's say we do it with z-score, right? So we'll do our two z-scores here. So our z-scores would be 31 minus 28 divided by 2, right? And then 27 minus 28 divided by 2, right? So upper and lower z values. Okay, so normal dot distribution. So C1 minus D1, so upper minus lower, comma 0, comma 1, comma true. Right? So we're doing it in terms of z-score, right? So we should get same answer. Whoa, wait a minute. What did we do here? What did I do? Oh, it's 2, not 1. 2, 2, 2, 2, 2, 2. There we go. Wait a minute. C2D2. What did we do? 31, 28. Oh, that's not right. What am I doing? Minus. That was silly of me. Why did I subtract the values? That would just be giving you a different z-score. That was silly. Why did I do that? I know better than that, right? Because that was just giving you a different z-score, right? So it's the area to one z-score minus the area to the other z-score, right? Okay, there we go. I don't know why I did that. And a brain blip there for a second. Okay. All right, so the first version we did was left to right, which is pretty straightforward. The second version was the between one, which means we had to actually do a little bit of extra math because it was between two, so to subtract the two values essentially, right? Okay. All right. So the last one is a left to right scenario, which means I have to do 1 minus to get the actual value. So it's going to be the garbage one again, essentially, right? Okay. So if we do that one, we're going to do 1 minus normal dot distribution. Okay, let's get this out of the way here. So we want to be average 28. We want to know more than 30.2 pounds of trash. So comma 28, comma 2, comma true. Okay, so more than 30.2. So that's going to be about 13.5, right? So this is about, come on, this is about 0.135, right? Probability of the household using that much trash, which is 30.2 pounds or more, correct? Where the average is 28 and the deviation is essentially 2. Okay, let's say we do it in terms of z, right? Be the same idea. So we can do 1 minus normal dot distribution, right? So I do the z-score, 30.2 minus the 28 divided by 2, right? So comma 0, comma 1, comma true. Okay, so I have it all, the z-score in there is all instead of a different box this time. Okay, then we get the same answer. Okay, so what we've illustrated is in all three scenarios, you can do this in terms of z, or you can do this in terms of the actual values. It won't really matter. You do not need to do it in terms of z. You can just do it in terms of the regular values when the question's asked, right? Unless it asks for z specifically, right? So in all three scenarios, you can just do the left scenario with the actual values. You don't need to do the z unless it's asked for, essentially, okay?